Imagine standing alone, not on Earth, but on a world scorched by fire and frozen by silence. A world so close to the sun, it should be empty of surprises. Yet, as the night stretches on endlessly over Mercury's battered surface, you raise your instrument to the stars and see something no one expected. A whisper, a glow, a ghostly trail of light, stretching millions of kilometers into the dark. Mercury, our innermost planet, is growing a tail. But not a tail of dust or ice. A tail of sodium, and it's rewriting what we thought we knew about planetary science. Before we dive into this celestial mystery, make sure to subscribe to Science Beyond the Lab, where we explore the hidden stories of our universe with wonder, science, and soul. Like, comment, and share this video if you believe space still holds untold secrets. Mercury, a dead cratered rock scorched by the sun. The last place you'd expect a tail, let alone one 2.5 million kilometers long. Not icy, not dusty, not comet-like. And yet, in 2001, astronomers saw it. A spectral extension flowing behind Mercury like the veil of a ghost bride. How did no one notice before? Because this tail is invisible to the naked eye. It's made of sodium atoms, tiny, fast, and glowing only in a sliver of light. 589 nanometers, the hue of ancient street lamps. At the McDonald Observatory in Texas, scientists weren't hunting tails. They were studying Mercury's thin exosphere using sodium filters. But what they found changed everything. A sodium emission, long, luminous, and trailing behind the planet. At first, they thought it was an error, but it wasn't. Mercury, a planet with no atmosphere to speak of, was venting a stream of atoms into space. And this wasn't some local puff of particles. It stretched 700 times the planet's own width. How? The answer lies in a cosmic storm of forces, blistering solar radiation, micrometeoroid impacts, solar wind bombardment, and one subtle but powerful force, light itself. Close to the sun, Mercury is relentlessly battered. Its surface is pelted by tiny dust grains moving at tens of kilometers per second. Each grain slams into rock, vaporizing material, liberating sodium. Meanwhile, the sun blasts charged particles like a cosmic sandblaster, stripping atoms away in a process called sputtering. But the most poetic thief? Photons, tiny particles of light, without mass, yet carrying momentum. Each sodium atom that absorbs a photon is nudged away from the sun, again and again. A cosmic push, a shimmering ballet. Solar radiation pressure stretches Mercury's sodium cloud into a vast, flowing tail. Like tiny solar sails, the atoms are pushed into the void, faster than Mercury's gravity can pull them back. This tail isn't always visible. In fact, Earth can only see it under near-perfect conditions. Mercury must be at just the right angle, away from the sun's glare. And 16 days after perihelion, when Mercury slingshots away at its highest speed. Why 16 days? Because of Doppler shift. As Mercury speeds away from the sun, the sodium-specific light is no longer blocked by the sun's own sodium. That spectral fingerprint is freed, revealing the tail like a hidden message in the light. But what does this mean for science? Mercury's tail teaches us more than just about Mercury. It hints at the way stars sculpt and erode worlds across the cosmos. If this tiny planet can produce a 2.5 million kilometer tail, what about the massive, hot Jupiters orbiting tight around alien suns? Could their sodium trails be even grander, visible light years away? We're already applying these methods to study exoplanets, using spectral signatures to detect lost atmospheres, planetary erosion, and more. Even Earth's own moon appears to shed a sodium tail. And with missions like Bepi-Colombo soon to orbit Mercury, we're about to see this ghostly tail in more detail than ever before. Mercury is often ignored. Too small, too close, too scorched. But now we know, this tiny world has a story. A tale, a mystery, a message. It whispers to us in sodium light. Even the quietest planets can sing. What else might be hiding in plain sight, waiting for us to look with new eyes? If this story inspired wonder, drop a comment. What other silent worlds do you think are keeping cosmic secrets? Like this video. Subscribe to Science Beyond the Lab and keep exploring, because the universe never runs out of surprises.